Okay, well, now we are on the other side of the Saddle Mountains. So we are on the north side. When we were at the White Bluffs, we were on the south side of the Saddle Mountains. And look, we're finding a lot of the same material that was on the south side. And this is where they found a huge variety of fossils. Mammoth, sloth, rhinoceros, camel, badger, just a smorgasbord of fossils in this area have been uncovered. Fossil bones that come from all parts of the world found all right here. It's really amazing. And there's other fossils that have been found that I just can't remember to name. So this is pretty amazing right here. This is really cool. I was just walking along and lo and behold, we found some ripple marks here in the hardened mud. Now, like I said before, the evolutionists are saying that this here is an ancient lake bed. Well, I'm sorry, but this is another example of why this cannot be an ancient lake bed, because we're finding ripple marks in the mud, in the hardened mud right here. And of course, I've shown you other evidence that there's no way that this could be an ancient lake bed. And you see, you have to understand, the evolutionists are very biased in this sense of the word, because they're trying to distance themselves as far away from catastrophism as they can. I mean, they can't even stand the idea of the Missoula flood, and so they converted it into the Missoula floods, and we have lots of evidence to show that there was only one Missoula flood. And so, anyway, this is example, once again, of catastrophism. This whole area here in the White Bluffs is examples of mud flows and avalanches, mud and dirt and rocks being carried probably all the way from the Rockies and northern Idaho. And you can see that this mud flow, it was 10, 20 miles long at least. In fact, in the sunshine, right there, I can actually see green in some of the layering. That's volcanic ash. Volcanic ash right there. This is almost kind of looking like the John Day fossil beds. Okay, behind me here is a huge mud flow. You can see it, it's just obvious. I mean, you don't have to be a rocket scientist to figure this one out. I mean, you just visualize in your mind what mud would look like, and that right up there is hardened mud. And what's really interesting is that midway up this cliff here, we find a very thin layer of what some people would call river rock. You know, it's about 2 feet thick. And behind the camera here in front of me is the Columbia River. And so a lot of people, they just naturally think, oh, well, that's river rock. After all, you got the Columbia River flowing through here. And so therefore that has to be river rock. I'm going to tell you something, that is not river rock. There's no way that it could be, because it is in a mud flow. You see, the truth is, people, is that if you could put a river in just about anywhere, if you could just drop a river almost anywhere, and if that river flowed long enough, it would start to uncover what we call river rocks. You see, these so-called river rocks are not laid down by a river. This is laid down by a mud flow. Catastrophism, not slow gradualism, like what the evolutionists would like to tell you. Looking across the valley, we see the Saddle Mountains. The Saddle Mountains is full of petrified wood. People have been digging up petrified wood and petrified logs for decades. And as we look across the valley here, we see Mount Rainier in the background. And you'll notice this huge flat valley. Well, this is where the Missoula flood came through here. And as we continue to pan over here, you'll notice the Rattlesnake Mountains. Rattlesnake Mountains is full of petrified wood. And so when the Missoula flood came through here, it got dammed up over here just south of Pasco, and it became a huge lake, and we call it Lake Lewis. So this was all covered by water a second time, and the water covered all the way towards Yakima, up to and beyond Othello, Washington, I believe up close to Moses Lake. And so this was all covered once again by a flood. And this was due to the Ice Age after Noah's flood. So there's a lot to see here, lots to think about. Okay, here we can see again a lot of mud flow activity out here in front of us. And when we examine the rocks, we can see what kind of rocks was in the mud flow. And it kind of gives us an idea as to where it came from, as to where the mud flow came from. And here we're finding granite or granodiorite. And we're finding a mixture of basalt. And look, almost all this rock is rounded. And then we come across this very curious piece of rock. Look, this is green. I mean, this could be schist, or it could be serpentinite. And that's really amazing. That's metamorphic rock. And then we come over here, and we find quartzite. Look at the bands in that quartzite. See, this is all evidence that there's no way in the world that this could have been a lake at one time. This is a huge mud flow that carried all these rocks, a huge smorgasbord of rocks from hundreds of miles away, probably the Rocky Mountains, or at least the North Idaho portion. So, you know, you look at these rocks and you think, wow, if the rocks could talk, what would they tell us? Okay, here's something that is like totally awesome. This will make any geologist, especially a catastrophic geologist, just put you in awe, basically. Okay, let's get some perspective here. Here's where we're at. There's the Columbia River over there. There's where the Missoula flood came through. And we come back over here and look at this. This is like totally cool. So what we got here, just get the sunlight to go in there. So here we got sedimentary layers that are almost at 90-degree angles right here. And then you got sedimentary layers that are going over the top of it and then going up. You know, they're bent. Something really weird was going on here. Maybe like an earthquake when all this was being laid down. And it's very obvious it had to be laid down quickly. I mean, look at this band of sedimentary dirt right here, or mud. Of course, this is hard as a rock now, but you notice this pancake-like layer, and then you come up here, and look at this. You've got waves of mud. Sedimentary layers like pancakes doing the wave. Maybe we ought to do the wave. And then look at here. We've got just very thin sedimentary layers, and they're all bent. This kind of reminds me of the wave of Pariah in Arizona on a much smaller scale. This is just amazing. And then on top we have all these pancake-like sedimentary layers, and now I'm going to look below it, and we have a lot of other pancake-like sedimentary layers just below it. So something was happening in here. Something in here was going on. Was it an earthquake? Something. But one thing is for sure. This is one big mud flow. A violent mud flow. Oh, and then we have it down here. I was supposed to look down here. Yeah. You have the same thing here. And then you go up here and it's like pancakes. And then you go up here and it's the same thing again. Yeah, pancake, the same thing again. And then look at here, we got it again. We got sedimentary layers that are doing the wave. Right. Well, that goes back there a long ways. That one goes back. Didn't bring a flashlight. Okay, here is a giant clastic dike running through these sedimentary layers. Now, these layers on both sides of the dike are laid down like pancakes. And so what happened was that all these layers, they got laid down quickly. So what you're looking at here is a giant mud flow. And there was enough water at the top of this mud flow to create enough compression pressing down on all these layers that there was a weak spot right in the middle here. There's a weak spot between these layers, and it actually pushed mud up through these layers like this, creating what is called a clastic dike. Now, this is more evidence to support the fact that all these layers had to be laid down quickly over a short period of time, and it all had to be mud. These layers were not laid down over an enormous amount of time, over eons of time. That's fictitious. We know that because of this clastic dike. This clastic dike could never be here if it wasn't for all these layers being laid down quickly and them being soft mud, water pressing down, and then this mud, it shot through this weak spot here, through these layers, and it created this clastic dike. So there you go.